So, welcome back to another question series for IIT JAM. We are solving the best of the PYQs, the most probable questions which can be asked in the next session of IIT JAM. And we'll move forward slowly to reference questions as you have less than 1 month remaining now. So, let's move to another good question. So, basically, this is the question based on NMR calculation. So you see, it says the resonance frequency of 1H nuclei or proton is 300 megahertz in an NMR spectrometer. And if the spectrometer is operated at 12 Tesla magnetic field, resonance frequency of the same nuclei will be. It says round off to one decimal place. It's a numerical answer type, basically net. And you have been provided the nuclear magneton value, nuclear G factor for the nucleus, that is the Landis G factor, and the Planck's constant. So let's look at what the relation is for this. So for these kind of questions, um, we'll go through a particular relation. Okay, just 1 minute while it refreshes. Okay, so we'll start with the question. So you are going to use this relation. The frequency nu is equal to your Gn, that is the Landis G factor, multiplied by beta n, which is already provided in the question, multiplied by B naught, which is the magnetic field, you divided by the Planck's constant. So this is your G factor. This is your G factor. Then you also have the beta n provided in Bohr magnetons. This is your Bohr magneton value. So your Bohr magneton value, and this is your magnetic field. Okay, so you can note this formula down, it's very important. Now if we come back to our question, so what we see from here is your mu is directly proportional to the magnetic field B naught. So if we come back to our question, it says, you see, uh, it says that the 300 megahertz spectrometer is provided. So, and the same spectrometer is operated for the second time at 12 Tesla magnetic field, and it's asking the resonance frequency. So, if you write down the parameters, so basically what you have is your, let's say, nu1 is equal to 300 megahertz. Then you have the value of the second magnetic field, that is 12 Tesla. But you do not have the value of the first magnetic field, that is B1, you do not know. And you have been asked about mu2 as the second set of frequency for 12 Tesla. So you have to first calculate B1 because you know that there cannot be two unknown values. You have to at least keep one set unknown, then you can find out with the formula. So we find out the first magnetic field here. Okay, so let's calculate the first magnetic field. So if you look at it, let's go with the formula. With this formula which I mentioned just now, you have been provided the value of 300 megahertz, which is equal to 300 into 10 to the power 6 hertz. Okay, then you put the value of Gn, that is your G factor, which in our case is 5.586. You write it down, 5.586, multiply it by the beta n, that is the Bohr magneton, which is basically your 5.05 into 10 to the power minus 27. 5.05 into 10 raised to the power minus 27. And then you have the units there. I'll show you how to play with the units there. Okay, so 10 raised to the power minus 27 multiplied by beta naught, you need to calculate and you divide this thing by 6.63 into 10 to the power minus 34. Okay, okay, so now you look at it. How to know whether you are on the right track or not? You just check out the unit. Just check out the units. So you need to find out beta naught here. You know beta naught has the unit of Tesla. So if you play with the units here, you see this is hertz. Hertz means second inverse. And you see on this side, this g factor is a constant. It does not have any unit. This, as you can see from the question, 5.05 into 10 to the power minus 27. This has the unit, you can see here. This has the unit joule per Tesla. Okay. So you put here joule per Tesla on the other side. Joule Tesla inverse, and B naught you have to calculate. Suppose B naught you have to find out, right? So let B naught be B naught, and you know this is the Planck's constant. It has the unit of joule. Okay, the Planck's constant, that is the value of H. You see the question, it has the value of joule second. Okay, is the value of joule second. So if you are going to find out B naught here, you're going to multiply second inverse with this thing, that is joule second divided by joule Tesla inverse. You see joule and joule cancels out. Second inverse and second, this will also cancels out. You are only left with Tesla inverse, and 1 by Tesla inverse is basically Tesla. So you know that you are on the right track when you put the formula together. Okay. So now we come back to the numerical that we were solving. Okay. So you see, if you perform these calculations all together, if you put these values, you have to just put the values together. So you are going to get your B naught value here. B naught value will come as equal to, I've calculated it beforehand, 7.0508 Tesla. Okay. So now you have this thing. And from this formula, I have already told you that mu is directly proportional to B naught. That is, the frequency is directly proportional to the magnetic field received by the NMR spectrometer. So you can look at this as mu1 by mu2 is equal to, suppose you can say this is B naught 1 by this is B naught 2, which means mu1 was provided to you 300 megahertz. You divide it by mu2, you needed to find out. B naught 1 we just now calculated 7.05 Tesla, and B naught 2 is already provided in the question, as you can see here. B naught 2 is already in the question, you can see here. It's 12 Tesla, operated at 12 Tesla magnetic field. Okay, so it's at 12 Tesla magnetic field. So you just have to put the values divided by this is 12 Tesla. So you just put the values and you get the answer. So basically mu2, how you calculate, basically mu2 will be equal to your approximately the answer will come out in the range of like 509 to 510 megahertz. Okay, so 509 to 510 megahertz. And you can also check the answer key. Basically this is question number 49 of JAM 2025, and this is 49. Yeah, look at it. 509 to 512 is the provided range. It's NAT type. So we got the correct answer. So this is how you had to approach this question. So please subscribe the channel for more questions coming up. I'll be uploading full-time videos as well. Once we get to reach a particular audience or a particular number of audience, I'll be starting with it. So please subscribe for further updates, and I'm going to bring quality questions to you from reference textbooks as well later on. So thank you.